Hello, everybody. I hope you're having a wonderful break. I know you've been anxiously awaiting the calc videos. I'm sorry it took me a little longer than I thought. But here you go. Here's the first one. Now, the one that you really have to do over break is improper integrals. I'm working on that one like right after I finish recording this one. I realized that for the L'Hopital half sheet I gave you, it was double-sided. The front was multiple choice. The back was 8 more problems. The back problems were very difficult. And I realized that when I assigned this, I hadn't taught you how to do the most difficult type of L'Hopital problem. So here you go. It involves using logarithms. So if you remember from the first L'Hopital video, I had this slide which I recopied here. So I had this slide, you already wrote it down, but I copied it again here to remind you, you can only use L'Hopital for 0 over 0 or infinity over infinity, that specific indeterminate form. Sometimes when you do direct substitution, you'll get infinity times 0. That means something needs to go in the denominator, which I'm going to show you quick because this actually came up on the half sheet on the back for number 7. Sometimes you'll get 0 or infinity minus infinity. That means whatever your expression is, you have to get common denominators and try again. And several times on the back especially, you get something exponential like 1 to infinity or 0 to the 0, infinity to the 0. Any of these, you need to transform these. And the way you do an exponential issue is using logarithms because logarithms will undo an exponent. You have to get 0 or infinity out of the exponent. The only way to do that is with logarithms. Let me run you through number 7 on the back. Because this one involves algebraic manipulation and it was a little bit trickier and it's not on Weebly right now. The others are. So I have x times tangent of 1 over x. You have to remember that anytime you see 1 over infinity, I know it looks weird, but it's 0 because if you divide 1 by bigger and bigger numbers, it gets smaller and smaller to 0. This ends up being infinity times 0. So I know I have to somehow do algebraic manipulation. You're going to put something in the denominator. So you could try putting tangent in the denominator. It would be cotangent. It would be a mess. I'm going to try putting x in the denominator. So you have to remember multiplying by x is the same as dividing by 1 over x. Because if you flip this to the top, it would be the same as having x times this. This is going to help because it will eliminate the infinity times 0 issue. Because once I flip it, now I have not done L'Hopital yet. I'm just manipulating right now. This becomes now tangent of 1 over infinity, which is tangent of 0. Now, instead of this being multiplied by infinity, which it was right here, now it's divided by 1 over infinity, which is 0. And now I get that 0 over 0 that I need. Now I can do L'Hopital's rule. So I do chain rule here. Derivative of outside is secant squared. Derivative of the inside is, well, I'm going to make it as, don't forget 1 over x is x to the negative 1. So bring the negative 1 down, subtract 1, negative 2, which is negative 1 over x squared. Derivative of the denominator, remember you do derivative separately of numerator and denominator, is again negative 1 over x squared. These cancel. Then I do direct substitution. 1 over infinity, I have secant squared of 0. Secant is the reciprocal of cosine. So the cosine of 0 is 1. Reciprocal of 1 is 1. 1 squared is 1. So make sure you have that fixed on your half sheet. Oh, wherever your homework is. Okay, so let's get to one that actually uses logarithms because that's the whole point of this video here. These do come up on the AP exam. They are probably the most difficult type of L'Hopital problem. L'Hopital can be really easy and it can be difficult, as you can see when you did the half sheet. Some of them were a little frustrating to do. All right, so I have number 5 on the back. Number 5 on the front actually also needs L'Hopital. Also needs natural logs. That's on Weebly right now under the worksheet handout. I'll show you that at the end of this. So anyway, go to where you did this and fix it because I'm assuming you had issues with it unless you happen to look up how to do this. When I do direct substitution, I end up with e to the 0 is 1, 1 to infinity. So I definitely need logarithms here. The method that you're always going to use if you have an exponential issue and you're stuck is you're going to assume that the limit exists. And we're going to let the limit equal y. You could also let it equal L for limit. It's up to you. It'll be the same thing in the end anyway. And then we're going to take the natural log of each side to bring down the exponent because we are going to use this exponent rule here, which says if you have the logarithm of some exponential term, you can always bring the exponent out front and multiply by the logarithm. It's the same exact thing. So you did that in Algebra 2. So I'm going to say, all right, let's assume that this limit exists, and let's let that limit equal y. I'm going to do the natural log of each side. What you do to one side, you do to the other. And I just rewrote it here with the ln. Now, I can't apply this exponent rule because the limit is right here, and I need the limit to be in front. There is a proof of this, but because of continuity, you can take this limit and put it out front. And instead of the natural log of the limit, you can do the limit of the natural log of this term. Now that I have ln of some exponential term, I can now bring this right in front of the logarithm and do the limit of that whole thing. What I did is I rewrote it with the 1 over x in front. Then what I did is I took 1 over x, multiplied by 1 over x. This is the same as just dividing by x. Now when I try direct substitution, again, I have not even done L'Hopital's rule yet. I'm still trying to manipulate this to finally get an indeterminate form. So now I'm going to try direct substitution. E to the 0 is 1. Hooray, I finally get 0 over 0, indeterminate form. Now I can finally do L'Hopital's rule now that it's in an acceptable indeterminate form. Let's go ahead and do L'Hopital now. So I can do the derivative of the numerator and the derivative of the denominator separately. Derivative of natural log, I'm going to do 1 over e to the x plus x times the derivative of what I just put in the denominator. So e to the x plus 1 all over derivative of the x, the denominator, is just 1. So this is going to be natural log of y. Let's clean it up a little bit. X going to 0. Now this is, going to 0. So I'm going to combine this to be one fraction, e to the x plus 1 all over e to the x plus x. Let's go ahead and try direct substitution here and see if we get something that works. Okay, I have e to the 0 plus 1 all over e to the 0 plus 1. Just caught a typo here. That's an x, so that's going to be an x. E to the 0 is 1. 1 plus 1 is 2. E to the 0 is 1. 1 plus 0 is 1. So I get 2. The only thing to be careful of, an AP exam knows that people make this mistake. So one of the choices on that multiple choice would be 2. 2 is not your final answer though, because natural log of y is equal to 2. And we assumed that y was the limit, so I want to find y. The only way to undo natural log of y is to exponentiate with base e, because e and natural log cancel. So my final answer is that y, my limit, is equal to e squared. And that would be the choice that you would pick on the multiple choice. So there's another example here that is very similar. I want you to try this one. I'm going to go ahead and pause for a second here and put up the answer. Try it on your own. See if you can manipulate it and use natural logs correctly. And then you can come back and check your answer. Okay, so you should have tried this on your own. Check your first steps to make sure that you manipulated it correctly. I haven't done L'Hopital yet. I just used logs and rewrote it. First of all, did natural log of each side, brought the limit out front, brought the exponent down front to get rid of that 0 to the 0. I tried direct substitution here. I get 0 times negative infinity. Natural log of 0, you have to keep in mind this is approaching 0 from the right. The graph of natural log looks like this. So as I approach 0 from the right, my graph is going down to negative infinity. So this doesn't work. That means I have to flip something to the denominator. I tried throwing this in the denominator. Multiplying by x is the same as dividing by 1 over x. Now natural log of 0 is negative infinity. 1 over 0 is infinity. It works. So now you can go ahead and apply L'Hopital. Go ahead and check your L'Hopital's rule. Natural log of x, the derivative is 1 over x when I apply L'Hopital. Derivative of 1 over x, remember 1 over x again is x to the negative 1. So the derivative of that is negative 1x to the negative 2, which is really this. Now before you even try doing direct substitution again, always clean up if possible. Where's my thing? So dividing two fractions is the same as multiplying by the reciprocal of the denominator. X and x cancel, leaving me with negative x. Plug in, you get 0. So you should have ended with the statement natural log of y is 0. You exponentiate each side. And then you can say that y, which is your limit, is e to the 0, which is 1. So your final statement is this. And again, this wasn't a multiple choice one. This is on the back. But if it was multiple choice, this would obviously be one of the answers, and so would 0, because 0 is the primary distractor, because some people stop too soon before they exponentiate. Make sure you realize that on Weebly here, I have the answer key for, this is under worksheets. Oh my God. Under Calculus Quarter 3 worksheets. There we go. Okay, this is the multiple choice ones. Please check number 4, because during the test, I checked a lot of your work, and some of you did FTC Part 2 incorrectly. When you do the derivative of the top right here, derivative and integral cancel, so that means FTC Part 2 says you plug in your upper limit. A lot of you got the answer root 2 over 2, I want to say, or 2 root 2, because you didn't plug in 1 plus h, you just plugged in h. So yeah, check your answer here. Number 5 uses the same technique we just practiced in the video. Then you can go to the back. Here are the answers. 5 I just did with you. 10 is very strange. So take a look at number 10. I don't really like this problem that much. It's a little weird. It's not typical, but just read what happens here. And then number 11, you can't actually use L'Hopital's rule because sine of negative infinity and cosine of negative infinity, it's an oscillation. If you picture a sine or cosine wave, as you approach infinity or negative infinity, they just keep bouncing back and forth between -1 and 1. So you can't really say that it equals anything. Where am I right now? There we go. You can't even do L'Hopital, so I just did a technique where you divide everything by the highest exponent, which the highest exponent here is 1, so I divided by x. So I did 6x over x, x over x, and cosine of x over x. That leaves you with this. When you try direct substitution here, you end up with just 6. It works. This is a technique that comes up every now and then, so just keep that in mind whenever you do these. It's not as common, but it does happen. All right, so I will do the improper integrals one now, and enjoy the rest of your day.